Lesson: Model training, validation, and hyperparameter tuning. Effective model training, validation, and hyperparameter tuning are critical components in the development and deployment of artificial intelligence systems. As AI models become increasingly sophisticated, the importance of these stages in ensuring robust, generalizable models is paramount. Model training is the process where a machine learning algorithm learns from data. Validation ensures that the model performs well on unseen data, and hyperparameter tuning optimizes the model's performance by adjusting parameters that are not learned during the training process. Together, these steps form the backbone of successful AI model development, ensuring that models do not merely memorize data, but instead learn patterns that generalize to new, unseen scenarios. Model training begins with the selection of an appropriate algorithm, driven by the nature of the problem and the type of data available. For example, classification problems might leverage decision trees or support vector machines, while neural networks are often employed for image and speech recognition tasks. The training process involves feeding input data into the model and adjusting its parameters to minimize the error between the predicted and actual outputs. This process is typically done using a loss function, such as mean squared error for regression tasks or cross-entropy loss for classification tasks. The choice of algorithm and loss function is crucial, as it directly impacts the model's ability to learn from the data. A practical tool for model training is TensorFlow, an open-source library developed by Google Brain. TensorFlow provides a robust platform for building and training machine learning models, offering flexibility for both beginners and experienced practitioners. It supports a wide range of algorithms and allows for easy deployment across different platforms. Another popular framework is PyTorch, known for its dynamic computation graph and ease of use, particularly in research environments. PyTorch's intuitive design makes it an excellent choice for implementing custom models and experiments. Validation, a critical step following training, evaluates the model's performance on a separate validation dataset. This dataset is not used during training, ensuring that the model's performance metrics reflect its ability to generalize rather than memorize the training data. Cross-validation is a widely used technique here, where the dataset is divided into K subsets or folds. The model is trained on K1 folds and validated on the remaining fold. This process is repeated K times, with each fold serving as the validation set once. The results are averaged to provide a more accurate assessment of the model's performance. Hyperparameter tuning is another essential aspect of AI model development. Hyperparameters are configurations external to the model, such as learning rate, batch size, and the number of hidden layers in a neural network. These parameters significantly impact the model's performance and are typically set before the training begins. The process of hyperparameter tuning involves searching for the optimal set of these parameters to achieve the best performance on the validation dataset. Grid search and random search are traditional methods for hyperparameter tuning. Grid search involves exhaustively searching through a specified subset of hyperparameters, while random search samples a random combination of hyperparameters. More advanced methods include Bayesian optimization, which models the function mapping hyperparameters to performance metrics and selects hyperparameters that are expected to improve the model's performance. Bayesian optimization is often more efficient than grid or random search because it uses prior information about the performance of hyperparameter combinations. Libraries such as Optuna and HyperOpt facilitate these advanced tuning methods, providing flexible and efficient tools for hyperparameter optimization. Optuna, for instance, offers an easy-to-use interface and supports pruning of unpromising trials, allowing for faster convergence. Real-world applications demonstrate the importance of these stages in AI model development. For instance, in the healthcare industry, predictive models are used to forecast patient outcomes based on historical data. Ensuring these models are trained correctly and validated rigorously can mean the difference between successful interventions and detrimental outcomes. A case study involving the prediction of sepsis in patients revealed that careful model validation and hyperparameter tuning resulted in a model that significantly outperformed baseline methods, reducing false positive rates by 30%. In the field of natural language processing, hyperparameter tuning can drastically affect model performance. For example, tuning the learning rate and batch size in transformer-based models, such as BERT, has been shown to improve accuracy on language understanding benchmarks by several percentage points. This improvement is critical in applications like sentiment analysis and machine translation, where even small performance gains can lead to significant enhancements in user experience. Statistical analysis further underscores the efficacy of hyperparameter tuning. Studies have shown that hyperparameter optimization can lead to performance improvements of up to 20% compared to default parameter settings. This statistic highlights the potential gains from investing in thorough hyperparameter optimization, particularly in competitive fields where marginal improvements can confer significant advantages. In conclusion, model training, validation, and hyperparameter tuning are foundational to the development of effective AI systems. Through careful selection of algorithms, rigorous validation techniques, and strategic hyperparameter optimization, practitioners can build models that perform well on unseen data and provide actionable insights in real-world applications. Leveraging tools like TensorFlow, PyTorch, Optuna, and HyperOpt can streamline these processes, enabling professionals to focus on refining their models rather than getting bogged down in implementation details. As AI continues to permeate various industries, mastery of these techniques will be crucial for those seeking to harness the full potential of AI technologies.